Very briefly, you see here it's the Superior Craton, 2 billion years old. Okay, it's important because all the major mining camp, base metal mining camp, the same type of mineralization we have on our project here, are at the fringe of this craton. It's the same case elsewhere in the world. The only exception is Sudbury, because Sudbury just was created by a meteoritic impact. Uh, why it's important? Because in during the Precambrian, 2 billion years ago, the earth crust was thinner, and those craton was bound by fault, vertical fault that connect with the mantle, and that's where all the ultramafic magma could come up through those fracture and fault plumbing coming up from the mantle up to the surface. Now the crust is thicker, and you don't see that type of magma on surface anymore, except for one very teeny exception in Africa. So very important to be at the fringe of those craton. And it's the same case in Finland, in Russia, and in Australia. Uh, big copper anomaly in lake bottom sediment, surveyed by the government. Brian and other before him, in fact, acquire all the available terrain in this area. Uh, Access and infrastructure, you saw it. A bit of geology. The ultramafic rock, the rocks that are coming up as magma in Precambrian time, 2 billion years ago, are the violet rocks. Okay, the violet color on this slide, and it's the favorable horizon. That's a favorable type of rock that holds the mineralization. All the massive sulfide and the resource estimate that were done in the past are shown by those three star here, and it's the entire property cover more than 100 kilometers of favorable rock. Okay, today I will show you only 15 kilometer in this area, and why it is so important. And the rest of the property will be, that's where we will concentrate our exploration in the next couple of years. I'll show you why it's important, while we will be developing other target in the rest of the property. So the potential for discovery in this area is very high, and we have a great expectancy for the rest of the property that were barely explored in the past. Historic estimate, Brian discussed it a bit. Just here, we have the same type of rock as the Raglan mining camp in northern Quebec, the Kambalda camp in Australia, the Sakati camp in Finland, with one difference. This one is copper rich. Usually the other camp, you have the nickel content is twice as high as the copper. Here we have the reverse, the inverse. We have 2 times more copper than nickel. That's a good thing. There is other deposit like that elsewhere in the world. There is 2 reasons. Is because the magma, that mineralization within a type of magma, there is a bit less rich in magnesium than Raglan, for example. And also there was a lot of copper in the country rock that were assimilate within the magma. And I show you how a bit later. You saw that. I skipped this one. It's a bit too complicated. This cartoon I draw 4 years ago, I was working on a very similar, another project very similar to this one. It's from, it's an example from Australia, Kambalda camp. You have a very hot, very turbulent, very fluid, ultramafic lava digging, circulating, flowing within sulfide-rich sediment. Okay, while it's digging, it's a conduit. The hot lava assimilate fragment of the sulfide-rich sediment. Then you got a contamination in sulfide and in sulfur of the magma. So the magma become rich in sulfur. That sulfur will connect, there will be a chemical reaction with nickel, copper, cobalt, okay? to create base metal sulfide. Those minerals, those sulfide, are heavier than the magma, and they will precipitate at the bottom of the lava or the intrusive, okay, to create massive sulfide. So assimilation of sulfide-rich sediment, saturation in sulfur of the magma, precipitation of sulfide mineral, rich in nickel, copper, and cobalt, and precipitation of the precious metal. It creates massive sulfide. It creates blebs, or small, droplet, I would say, of massive sulfide, and also a net texture, like a fishing net. Okay, it's just liquid massive sulfide that with big crystal of silicate crystal. So the silicate crystal are surrounded by the sulfide, and the sulfide create a kind of a very nice texture we call net texture, very similar to a fisherman net, and it could be conductive. In Raglan, for example, half of the ore deposit, economic ore deposit, are a large volume of net texture with a small volume of massive sulfide. In other area, it's large volume of massive sulfide with a small volume of net texture. The important point to understand, okay, you see here the vertical section across the lava flow. If we find those small droplet of the blebs of massive sulfide or net texture close to surface, it's the best indication you could have a large volume of net texture and large volume of massive sulfide at the bottom of the lava flow. Different shape of that type of mineralization. The one in our property is the Campbell type. It's a flow, lava flows, like Raglan and Sakatti in Finland. It's been 4 years now that I'm working in that type of deposit. I've done a lot of research and study to find the main line of evidence for having a successful exploration. I'll skip those a bit technical, but here, the most important one. When you find a pregnant or fertile conduit, magmatic conduit or lava flow, if you find one that is fertile, that means fertile mean with evidence of massive sulfide or net texture or bleb, okay, the best strategy in exploration is to continue to follow the conduit, because usually there is more than one massive sulfide, there is more than one ore body within one conduit. That's the very important. That's the main exploration strategy in Australia, in Raglan, northern Quebec, and in elsewhere in the world. I'll show you some example I skipped. So that's from Australia. It's a plan view, it's a cartoon. It's lava flow, ultramafic lava flow. In green, it's basaltic. Ultramafic lava flow, like in purple and it blue purplish, like kind of. Those are conduit, volcanic conduit. Some of the conduit are pregnant. Some mineralization at the beginning of a conduit. The best strategy to find more mineralization is continue drilling the conduit. You could hit a second ore body or a third ore body. You have a pregnant or a fertile conduit, follow the conduit. An example from Raglan. Here it's a bit different. It's a vertical section. It's a section through one of the ultramafic conduit. The ultramafic is in violet here, purple. They found a small deposit, subeconomic, close to surface. That told them that this conduit was pregnant, was fertile. They continued drilling and they found an ore deposit, economic deposit. They continued drilling. They found a third one, a second one, and a third one. You got a fertile, you got some interesting mineralization, even if it's subeconomic, okay? You continue to drill your conduit and you can find ore deposit. I'll show you another example from Raglan later. Example of how the two big nickel copper rush in Australia. First was showing from surface. That's where they had the majority of discovery. After that, it was geochemistry, geophysics, drilling, not a lot of success. Then the second boom, okay, was just follow up known mineralization. That's when they realized when you have a fertile conduit follow the conduit, you can find more mineralization. And in Australia, they were very successful. Raglan is the same. Now, very quickly, I'm showing you a zoom on our property. The color is the first derivative of the magnetic survey that was done in 2010. A high quality VTEM airborne survey. Okay, the red color and orange color are high anomaly. Okay, the blue color are low anomaly. What is important to look here is that the contour in blue are the surface projection of the known mineralization at depth. Okay, you have the Pogo deposit here. It's 1 million ton something. And you have the Blue Lake deposit here. It's 1.3 million ton. Look at the side of this one. You have the scale at the bottom, 2 kilometer. In fact, it's two lengths. The first length is here, 600 meter, and the second length is here, something like very close to 400 meter. What's important to look at the mag, the color, okay, is that the known mineralization is shown by some anomaly here. But those anomalies are not, well defined. We call that mottled texture, the kind of anomaly we have. And it's variable going down there. You see mottled. It's not big anomaly like this one or this one, for example. So it shows, okay, where the ultramafic are located. Okay, that's magnetic signature of the ultramafic, and the dashed line are electromagnetic anomaly. Electromagnetic anomaly are could reveal electric conductor like massive sulfide or barren massive sulfide or economic massive sulfide. Sometimes it could be graphite, something conductive. Those are the dashed lines. So you see the short conductor compared to very long conductor, following those mottled magnetic texture. I'll talk about this area here. In this area, the lava flow, I saw it on surface. I show you some picture of those things. The lava are flat, horizontal. This mineralization here, Blue Lake, 1.3 million ton, is sitting at the bottom of the lava that I saw on surface at 100 meter below surface. So this lava flow is 100 meter thick. I saw surface expression in the ground, on surface, and the drilling. All those circles are the drill holes that were done in the 80s and the 60s to define the known mineralization. And all the drilling stopped here because mainly, Brian mentioned it recently, is because they didn't have the claim, they didn't have the property going to the south. So what we're seeing here, what I've seen, that's my interpretation, okay? You have massive sulfide here, and you see a conduit, a lava conduit here that we defined by the mag and bound by those EM anomaly going there. A second conduit here, fertile conduit, because there is massive sulfide at the bottom of the lava in this area. This one is a very nice one, a large conduit, a long conduit, massive sulfide at the bottom of the lava, another fertile conduit going like this, a fourth conduit here with this mineralization, and a fifth conduit. All are fertile conduit. This corridor is 1.5 kilometer wide, okay? And from this part here, it's flat lying. Why it's important? That corridor, okay, I was looking this area to you with the known mineralization and all the drill hole, those red circle, all the drill here. The main drilling stop here. You have two very old drill hole here, one here and one here. On my 3D model, I clearly see that those two holes were too short. They never reached the bottom of the lava flow, of the ultramafic flow. So what we have here, we have a 1.5 kilometer wide, 12 kilometer long corridor that is made of half a dozen fertile corridor that were never been drilled over 12 kilometers. It's subflat. It's dipping 2, 3, 4 degrees to the southeast. So here, the bottom of the lava is at 100 meter. And I extrapolate that in this area at the end of the corridor, it's at about maybe 200, 250 meter deep. That means very shallow, very easy vertical drill hole to test the entire area. We will need a lot of drilling, maybe 2, maybe 3 drilling campaign. But we're going to start with in this area. What I saw in the field when I was there, after the first visit with Brian in August, I went there for 10 days at the end of September to have a look at a lot of other features, geologic feature. I found a surface expression. I show you how I identify it in this area of ultramafic lava, in this area, and in this area. And I found 3 evidence of net texture on surface. Net texture that I showed you in the cartoon in this area, and this area, and 1 teeny bleb in this part. Just to remind you how it's important. On this slide, net texture close to surface, 3 spots that I found, okay, along that corridor, and 1 spot of that type of bleb. When you see a bit of those textures, sulfide, close to surface, within the lava, you could have a good chance to find a lot more at the bottom of it. Chance, there's no guarantee, it's exploration, but there's no better target. It's a great exploration target. Whoop, sorry. I went too fast to the wrong direction. Yeah. This one. Okay. We're looking at in red, I draw the contour of that high potential corridor. Everything is flat from here to here. Okay. There's still some interesting target, some extension close to the known mineralization, obviously in this area. But from here, going northwest, the same geology continue, but here, because it's fold, here the geology is not flat. The geology is 35 to 45 degree deeping to the southeast. There is still some old showing that were found with just a couple of holes. So basically underexplored. And we found during last summer, our young geologists found another new showing in this area with an ultramafic, and another showing in this area with an ultramafic also, with new airborne anomaly that we got from the airborne survey we've done during the summer. So high potential corridor, very high potential for this new discovery in this AZ drilling, subvertical drilling, shallow drilling. Going up there, it's like raglan. Everything is deeping at 40, 45 degree, same type of exploration, geophysics and geology, geochemistry. And while we'll be working on this area, it's our first priority. We'll continue to develop new target elsewhere on the property. You're just here showing maybe 10% of the property on this picture. So lots of potential. Brian and people before him had the good idea to stake all the favorable rock in the region. Again, at Blue Lake, the main line of evidence for exploration, it's about the same. I just adapted for my young geologists. Fertile conduit, follow the conduit. That's the best strategy. Another example from Raglan, a vertical section. Here, I didn't have to modify this slide, but the ultramafic lava is an orange, not in violet like the one before. But on surface, they had some net texture, disseminated texture mineralization that they drill. No success, just disseminated. They continued drilling. They found a small subeconomic deposit here, okay, close to surface. The strategy, you got a pregnant, you got a fertile conduit, you continue to drill the conduit, you follow the conduit. They continued drilling, going down, and they found this one, 38 meter at 3.4 nickel and 1% copper. That's very high grade. They continued to follow the conduit. They found 3 more lands, economic lands in this area going deeper. The problem with that type of geology, and that's a problem we're going to have with the rest of the property, it's dipping at 40 degrees. When they're down to 1,000 meters, it's too deep for the geophysics, and it's very expensive to drill. The advantage we have on our new corridor, if this thing is subflat and the deepest part is at 250, 300 meters under the surface, over 12 kilometers. So that's the beauty of this area. That's why I call this new interpretation a game changer. So some example from Raglan, a bit of geology, nothing technical. This picture was taken here, about 400, 500 meters from the main mine, the Catilinic mine in Raglan, northern Quebec. Okay, it's still in operation. Brian have all the history. This picture was taken with a helicopter. You see columnar jointing within the ultramafic lava. It's the top of the lava. Columnar jointing mean quick cooling of the top of the lava. It means the top of the lava was in contact with water or water saturated mud. That means it's a lava, or we call a very shallow subintrusive that was in place under the mud. Okay, quick cooling, columnar jointing mean quick cooling, and a bit of disseminated mineralization. You have a geologist, she's there for the scale. Okay, so we can deduct that's the top of the lava, and we have maybe the first 12 meter, 15 meter of the lava. Okay, and the massive sulfide mineralization is something like 50, 60 meter below this point. Okay, that's columnar jointing on the top of the lava, some mineralization, and the mine, the ore deposit, are 60, 50 meter deeper than this part. I took this picture last fall from the chopper, another young geologist, to give you the scale. This is ultramafic lava, columnar jointing. I'm the first to have recognized columnar jointing on this property. None of the old report were mentioning it, and I recognize it in the first 10 minutes in the chopper. I told Brian, whoa, we stop here. Those are columnar jointing. Fortunately, a young geologist who worked on the property last year and during all this summer were not aware what was columnar jointing. But when I saw that, I say, well, very, very typical of the Raglan style of mineralization. We see the top of the lava. We see maybe 12, 15 meter. The known mineralization is maybe 80, 85 meter below this point. Exactly same type of geology, exactly same type of ultramafic lava. The only difference, this magma originally was less rich in magnesium, and that's why the mineralization we got at the bottom of it is copper rich. And as Brian mentioned, copper, most likely, copper will be the lead metal for the electrification that everybody predict the boom of electrification for in China, in India, and Africa. So copper has a bright future as a metal, and we basically have a copper project.